The following lesson is a presentation of PrepLogic's LearnSmart Video Training. To find out how you can get unlimited access to our entire LearnSmart Video Training library, call 1-800-418-6789.
The entire goal of networking is to provide resources to users when they need them. So the whole concept of network optimization is a pretty important one for us. Let's talk about some of the big issues that come into play with network optimization. Probably the first great example would be high bandwidth applications. Certain applications just take up a lot of your bandwidth. Now, there's no absolutes here, but it just depends on what your network does. If you're doing a lot of FTP, then that's your high bandwidth application. If you're doing a lot of file sharing, then that's your high bandwidth application. The other issue is high availability / uptime. For example, at my company, we have an on-site presence where you can buy videos and books and all kinds of stuff that Mike Myers makes. In those types of situations, if somebody wants to buy something, by gosh, I want to make sure that my website is available and that I have very little downtime. I want it to be up all the time. The third area is latency sensitivity. Certain applications just hate it when they have to pause or wait. Probably two best examples of that would be voice over IP or video applications. Fortunately, we've got some pretty basic solutions. For example, one good example would be traffic shaping. By traffic shaping, we're defining on a port-by-port or application-by-application basis how much bandwidth a particular port or application might get. We can also provide network optimization through caching engines. For example, a proxy server that allows all of our users to go through a proxy as opposed to going to individual web pages. Next would be load balancing. Now, when we talk about load balancing, what we're talking about is quality of service in my view, and I'm going to show you that in just a minute. But one more I want to throw in real quick is bonding. Let me show you how bonding works. The whole idea behind bonding is to use more than one network card to act as though it were exactly one network card. In order for bonding to work, you have to have drivers that are sensitive to the concept of bonding. You configure the drivers to say, these two particular network cards are going to be working together. Once you've done that, you'll have one IP address assigned to both cards, and basically they act, bark, smell, taste as though they were just one network card. You run two cables into the switch, and you just enjoy the benefits of doubling your bandwidth by doing nothing more than making sure you have the proper type of driver. Now that's bonding. Traffic shaping is kind of unique among optimization methods because it's got a bit of a bad rap. For example, I use the popular Comcast for my internet service provider at my house, and Comcast uses traffic shaping in ways, for example, if you do too much BitTorrent peer-to-peer type stuff, Comcast actually has devices that watch your traffic. They watch what's happening, and if you do too much of that, they turn the knob down on you, and you have absolutely no say on it. Now, we can do traffic shaping too, but to me, traffic shaping means quality of service. The nice part about quality of service is it's a control that works even on a small home router like the one I'm about to show you, and it allows you to make fairly fine controls about what applications get what kind of bandwidth. Let me show you. So here we are back at my good old WRT54G, and I'm going to dive in here. And if you see right here, do you see where it says QoS? Now, what I'm going to do is I'm going to turn QoS on, and I can say which port I want it to run on. The only thing I'm worried about is my uplink, so I'm going to leave it as my WAN port. Now, I need to give it some values, what my uplink speed is, so I'm going to pretend like I have a ADSL. So I got a 768 upload and a 3 meg download. Now, if you take a look here, get you some idea of some of the options we have. Here's a services priority. So let's say I've got a problem with people doing way too much BitTorrent. So I'm going to go ahead and change BitTorrent. This is just a nuance. I have to hit save. It grays itself out. Then I have to hit save. It's part of the fun of dealing with some of these routers. There we go. Now, you can see that I've put BitTorrent as a services. Now, what I need to do is set its priority. The priority, it depends, different QoS applications have different ways to handle it, but on this particular one, it basically gives 5 levels, which is exempt, premium, express, standard, and bulk. Exempt means it's not part of the process. What I want to do is set it as bulk. If I have an application that's running at premium and another application that's running at express, the premium will get precedence over express. Express gets precedence over standard. Standard gets precedence over bulk. So it's not really a percentage thing. It's just a matter of who gets priority depending on what's running. So I'm going to set him as bulk. And you got to hit save again. Now, while we're waiting for that save to kick in, we can actually look at a few other settings here. I can also set priorities for a particular IP address. I can set priorities for a particular MAC address. And this one's fairly interesting. I can actually set priorities for a particular physical port. There is a 4-port switch on this little router. And let's say I have a web server that absolutely always has to get through on port number 2. I can set that up and give it a really high priority to make sure that no matter what happens on that port, he always gets a priority. The important thing to understand with optimization, and QoS in particular, is that there's always nuances to it. It's something you don't just set once and leave alone. You tend to tweak it and play with it and adjust it until you get it the way you like it. You never stop playing when it comes to network optimization.